And over there, what do I get? 2i, yeah. So plus or minus 2i. Then you add 2. So you get x equals 2, give or take 2i. And I don't go any further because 2 and 2i are not like terms. If it was 2 plus or minus 2, well, then I get 2 plus 2 is 4, and 2 minus 2 is 0. 4 and 0 are my two answers. So if they were like terms, I would put them together. Okay. Oh, shit. Some other class sneaks in the middle of my class. Okay, so. This is, I think, the last level we'll do today. Well, okay. So this is the last idea for today. It'll just take 20 minutes. No. Some amount of time. So it seems as if, let me see if you guys agree. It seems as if when it's in this kind of form, it's relatively easy to work with, right? So if it's not in that form, a good first step would be to try to put it in that form. Now, especially, so for example, let me show you a little bit of this. Well, yeah, Jeff, that makes sense. What is the actual very first thing you try to do here? Factor it. Will this factor? Quickly you can tell, no freaking way. There's no factors of 1 that make 4. Bullshit. It's a very overachieving 1. It ain't gonna work. I'm gonna try to make this, well, let's see. Right? All right, now watch. This is going to require us, how in the world do I create something that looks like this from here? That's kind of like the part we got to work on now. Because if I could just make this look like that, I could do it easy. All right, now stay with me. What is, this is kind of cool. What is this? What is that? Multiply that for me. Yeah, so x plus 1 times x plus 1. So what do you get? I like it, right? Let's do another one. What is x plus 5 squared? Whispering to yourself the answer. Alright, you're all like, wow, Jeff, amazing. And but watch this. Where'd that 2 come from? 1 plus 1. So, and where'd that 10 come from? 5 plus 5. So what number seems to be here if I know this number? Half of that number, right? So for example, if it was x squared plus 6x, I'm going to leave this blank. There must have been a 3 in here, right? Because if I do x plus 3, 3x and 3x makes 6x. That middle number is always twice what was in here. Why does it make sense? Because I get it once and again. I get it once and again. So of course the middle stupid number is twice the number that was in there. Let that be just like, yeah, of course it is. Is that decent? I mean, we could do several more examples, but I don't care what number I put there. Same thing's going to happen. It's going to show up twice. Where's that last number come from? Yeah, that number squared. So if I know this is 6, how do I figure out what was here? Cut it in half. That seems to be the first step. Now, how do I know what has to be here? Square that number. That's the second step. So the first step is, what's half of 6 is 3. And the second step is, what's 3 squared? 9. This second step tells me what has to be here, and the first step tells me what has to be in there. Go with me. I already see some of you guys are giving up. I'm sorry. Come on, stay with me. Stay with me. This kind of thing, we're doing something, what's called completing the square. Why do we call it that? Because I want to organize this shit so it becomes something squared. So I want to complete the square. That name makes complete sense. So what I do is this. Let me move that the hell out the way. Get out of here. Because what did I have here? Blank. And then I could figure out what had to be here was 9. So if I get that out the way, get over there. How do I figure out what has to go here? And how do I figure out how this will factor? This is so cool. Now, it's brand new to you guys, so just stay with me. I got a little handout that actually has a couple examples on it, so just stay with me. How did we figure out this was 3? No. That's how we figured out 9. How did we figure out that was 3? Took half. We have to do that first. So what's half of 4? And then what do I do to that? I take that and I square it to figure out what's got to be at the end. What's 2 squared? 4. So if I make this, if I add 4, what's going to be in here is 2. And check it. How do you factor x squared plus 4x plus 4? X plus 2, x plus 2. What's really weird, what's funny to me is the first step tells you what's going to be on the next line, and this step tells you what had to be here. Now what did I do to this equation? I added 4 to this side, so I better... Yeah, that's the thing that people forget all the time. So I had to add something to both sides to complete the square, to give it what it needs so I can write it like this. We couldn't factor this. Before today, it was impossible for us to solve this, at least knowing what we know. If you know quadratic formula, great. We don't officially know it yet, right? So what I get x plus 2 squared equals? 5. And now I can solve it. It wasn't in that form that I know how to solve, so the first thing I did was put it in that form. And now I know how to solve it. Now that process is new to you. But the motivation should make sense. If it's this form, I know exactly what to do. So let me put it in that form. So then I know exactly what do I do then. Square root. Plus or minus. I'll do this side. And this side's easy this time because what's the square root of 5? I don't freaking know. And then you subtract 2, so you get x equals negative 2 plus or minus around 5. Since it wasn't factorable, the answer is going to be weird. That's why the answer is kind of gross. Because if it was factorable, that's when I get nice fractions or whole numbers. And now fractions are nice. Compared to freaking radicals, yeah, fractions are nice. Yeah, let's do another one. Oh, let me give you the sheet first, actually. Let me do this so you can kind of follow what the process is. This is section 11.1 we're doing right now, by the way. So the side that says 11.1. So look at the first example. That's exactly like the one we just did, I think, except that is 6 on that one, right? Same kind of steps. The little box are the actual steps for completing the square. And I try to color code it so you can kind of follow where things go. Things get a little weirder on example 2. We knew that number 2 would be worse. Why is number 2 going to be worse in a way? Why is this kind of nice? Because factoring with a 1 out front is always easier. What does number 2 got in front? 4. So see, I have to divide it and I make fractions and oh shit, too bad. This whole process only works if the first number is a 1. So if that's not a 1, you have to make it a 1. So you have to divide and just live with the fractions it might make. Try to do number 1 at the bottom. Is that an ugly one? No, it's not too bad. That one's not too bad. Try it out. Careful with the negatives.
few steps, you should always do these steps on the side. So what's in the middle right now? -6.
Yeah.
So you cut it in half, get -3.
Yeah.
Then you do what to -3?
Square.
And you get what? -3 squared is?
-9.
No, 9.
9.
So you have to add 9 to this side, so you better add 9 to that side.
Oh.
So that's the step you don't want to skip. You want to show yourself what you're giving to that side. So what's the first step in this process? Yeah, so the first step was actually make room. I want a blank spot here so I can control that, so I get the 11 out the freaking way. Then you take the -6 and cut it in half. What's -6 divided by 2? No, -3. That's what I mean by careful with the negatives. So what's going to go in here? X minus 3. That's kind of beautiful if you let it be. I don't even have to think about factoring. It just, the first step tells me how it's going to factor. And the next step tells me what had to be there to make that work. I love that it's kind of backwards. I love it. I would. What's -3 squared?
9.
So you better add 9 to both sides. So now I get x minus 3 squared equals 20. And now I can do like we were doing before. Which is what?
Square root.
Square root.
Plus or minus.
Plus or minus. X minus 3 equals plus or minus. We did this earlier, remember? Rad 4 is 2 and rad 5 stays. And then you add 3, force that out front. Like this. So it is new, but you can see, hopefully you can see why it makes sense. It's the same idea we used before. Find a pattern, develop a process. That's what completing a square really is. The back of this sheet, by the way, we still got to do situation 2. Next time. But the back of the sheet, we've done the first method, obviously, that's factoring. We've done the second method, which is just taking the square root, like this, the last steps here. And the third method was complete the square to put it in the right form so I can do that. The last method we haven't talked about yet officially, but it's quadratic formula, which hopefully is familiar to some of you guys. Negative b plus or minus, all that kind of stuff. All right, we're going to actually prove where that comes from. That's going to be fun for me. All right, that's enough for today. Oh, I did say there'd be a quiz tomorrow. There's a quiz tomorrow. On what? I don't even remember. Huh? Yeah, tell me, because I might make it over more than I said.
Yeah.
10-1 to 10-5. Yeah, sounds about right. Okay. Tomorrow, 10-1 to 10-5. Sweet. I got that on camera, so I won't get it myself either. That's one reason why I videotape.